Hi, everyone. My name's Jose Diaz-Gonzalez, and as he said, this talk is about abstracting Nomad, the patterns for deploying to Nomad at scale. So before I jump into the technical meat of the talk, I want to talk about SeatGeek and like what we build, why we're building in this way, and that sort of thing. So SeatGeek is a high-growth live event ticketing platform. If you go to any sports, concerts, theater, animal sports, types of events, you probably have heard of us or you have used us. We partner with some of the largest names in the industry, such as the Dallas Cowboys, the Brooklyn Nets, MLS, etc. Right? So I want to talk about the problem space for SeatGeek and who we are, who our customers are, who do we partner with, and that'll give you a little bit of context as to what we've built and why we built it in this way. So on the customer side, we have folks who buy tickets to live events. So that's someone who wants to go to a concert or wants to attend, a sporting event to, see a basketball game or something like that. We provide an experience for them to find the best seats available, ensure that they have all of the information that they need when they attend an event, as well as, offering a great in-venue experience, right? We've also been massively fortunate to establish partnerships with some of the largest properties in the world. So like I said, it's the Dallas Cowboys or Manchester City, if you're a football fan on either side of the globe. We also partner with basketball teams such as the Brooklyn Nets, the Cleveland Cavaliers, and then we partner with a bunch of organizations such as Brooklyn Sports and Entertainment Global, as well as Hugh Jampton on the concert side or on theater side. So all of this, on the partnership side, we work with them to work on back office operations. So how do you run an event? How do you sell tickets? As well as, providing that experience for folks who are coming into a venue and actually checking in and purchasing tickets. So that's a little bit about the business. Now we'll talk about more pragmatic stuff. On the technical side, aside from, using a ton of languages and frameworks, SeatGeek services at SeatGeek are fairly generic and homogeneous in how they are built and how they run. All applications that we run load configuration roughly in the same way. On the consumer side, that means, SeatGeek.com. We load environment variables into a configuration object and read that kind of everywhere, regardless of the service. For partner-facing services, stuff that runs a back office for folks at our partners. They typically have a lot more configuration, but again, all of that is stored in XML files and loaded up in the same way. So if you're on the consumer side, it's all environment variables. If you're on the partner side, it's all via configuration files, pretty similar. All applications also communicate in roughly the same way. If you're an app developer, you have the option to send messages over HTTP across our internal service mesh to another service. And in rare cases, we do communicate via TCP, and then engineers are allowed to specify that they prefer either a TCP communication or HTTP, depending on how they configure their services. For longer running tasks, such as payment processing or email sending, something like that, those typically occur in a background process. An engineer can choose to send a message into one of our message brokers, typically RabbitMQ or SQS, and then process that work asynchronously, either within their own service or in another separate service downstream. Messages are largely sent in the same format. So if you're an engineer on a Python service, you can go to a .NET service and it's the same object that you're looking at. And then the background processing frameworks that we built process those messages in roughly the same way, regardless of what the language or framework is. Our resilience team has also gone to great lengths to standardize how we ship metrics and logs for our monitoring purposes. If your application makes an HTTP request to another service, we've enabled APM to track all of those requests across the stack. Applications are also shipping logs in a standard format wherever possible, and then we enrich them with platform level data so that we can isolate issues to regions or instances or any other number of dimensions. Metadata about where messages and metrics are generated are also injected into the log messages themselves, so that way we can use that during incident investigation or after the incident. This is all to say that the solution that we're building towards and what works for SeatGeek makes quite a few assumptions about how the systems work and how the services work, and that we're not expanding in terms of the number of options folks can use. Right? So what works for us may not work for your organization if you're not building into kind of a homogeneous environment. So with that context, I'll talk about our actual Nomad adoption. In the early days of Nomad at SeatGeek, we mainly experimented with Docker-based deployments. At this point, we use more than just Docker. We use raw exec. We're experimenting with other types of drivers, etc. The earliest test of Nomad was actually just to see how we can do and perform certain actions on the platform, right? The platform requirements are relatively simple. For everyone else, it would be when an engineer completes a bug or a bug fix or a feature, how do they get those changes from their laptop in front of our customers? If we want to route from one service to another, how should that be configured? What do we expose there? If an engineer wants to specify an application secret, for example, for payment processing, maybe they have a token or something like that, how do we expose that to an engineer, right? How do we ingest logs? How do we scale? Those are the kinds of things that we were kind of focused on really, really early on and what drove our initial investigation. So in the beginning, what we started using was just Nomad calls. And this was prior to the 1.0 era, so we didn't have access to HCL too. So a lot of it was just like playing around with set calls and saying, all right, fine, let's set the image, let's set the count, let's run that job. Today, if you're using HCL2, and I'll have an example of how that works, it's a little bit simpler. But in our case, deploying a particular commit SHA just required changing the image property and then submitting the job. If you wanted to scale, it's pretty much the same way. You set the count, submit the job. Application configuration was provided via template stanzas, so that was regardless of whether or not we were running things where they loaded XML configuration or if they were loading environment variables. And we had Consul-backed DNS already, so everything was just kind of communicating via our internal Envoy-based service mesh. Today, by configuring the correct HCL job file, these are much simpler tasks to execute for smaller Nomad installations. For many folks dipping into their toes into Nomad today, you can get pretty far along with the Nomad CLI and HCL templating for support. We recommend using the Nomad CLI this way for the following use cases. If you're using Nomad as a proof of concept within a new organization or like a new deployment, it's a really good place to just start and play around. You can stand up a simple Nomad cluster and submit jobs just to see how things run, right? In all honesty, you don't need a large deployment tooling or deployment platform if you're just playing around with Nomad for the first time. If you have a local home lab that you're playing around with, same thing. Just send up a simple Nomad cluster, submit those jobs directly. You probably have other things that you are concentrating on that you can better spend your time on. And then finally, if you're playing around with new functionality in Nomad, especially with new features that come out with every single release, before you build that into your tooling, play around with the Nomad CLI to submit those jobs and see how that actually runs and executes in your platform. While these two options weren't available to us at the time, it may be interesting for you to look into Levent and Nomad Pack. On the Levent side, it's a slightly improved method of interacting with the Nomad on the CLI. It allows for a little bit more flexibility around templating, including defining your own functions and that sort of thing, and overcomes a couple limitations in HCL2 itself around what kinds of things that you can template out. It also has a couple interesting ways of interacting with Nomad itself, and I think it's a really, really good option for folks with smaller clusters or home labs. Nomad Pack is also another entry in this space. If you're familiar with the Kubernetes world, it's pretty similar to Helm. If you're providing a library of applications, or if your applications are fairly similar to each other and you just kind of inject configuration, it could be a good option for you. All that aside, once we had our feet wet with job specs and our most common workflows with Nomad, we started looking at expanding SeatGeek's footprint and usage of Nomad. So we asked ourselves a couple questions. What were the pain points around deployments? If you're an engineer, how do you get your code up, and how do you know that it's up and running? What did we feel comfortable supporting on the platform side? Certainly we can build the world, but if we can't support the world, then we are better suited not to build all of those features and functionalities. And then finally, what is the best experience that we can provide to engineers? If we scope ourselves to a very small portion of what Nomad provides and provide a best-in-class experience for that, an engineer will be more excited and more likely to use the deployment platform to ship code. One decision we made early on was to allow engineers full access to what was deployed and how it was deployed. So if you were an engineer, we expected you to understand kind of the following concepts. You had to know how to write a Docker file. You had to know the various knobs in a Nomad HCL job specification. You had to know how Consul templating worked. You had to know how Vault and Consul integrated into our platform. This was a complete 180 from our previous deployments, where an engineer would have limited access to the underlying host, and they would be able to specify basically, here's the command I want to run and a couple of operating system packages. With Nomad and with HCL2, we provided a way for folks to completely define what they were running and kind of opened up the entire world to what they wanted to run on our platform. In practical terms, this meant that an engineer's interface to deployments was an infrastructure directory. So every single repository gets this infrastructure directory. You can define one or more job files. You can define one or more Docker files that we will build for you. You can define configuration, whether that's file-based or environment-based, for your applications for usage within all the processes within that app, as well as files for configuring how applications were monitored. The user journey for deploying to our platform was as follows. You would go to a deployments UI, called it Deli, it was short for delivery. You'd find your application and your environment configuration. So if you wanted to deploy to production, you'd go to prod and then find your app. Same thing for staging or any other environment. You'd select your commit that you want to deploy to that environment, which in certain environments was scoped to certain branches. So if you're in production, we would only allow the integration branch to be deployed. Whereas if you were in pre-production, you can deploy pretty much anything. And then you click deploy. Under the hood, what this would invoke was basically slurping down that configuration, modifying all of the job specs, injecting any commit SHAs, and injecting environment variable configuration, et cetera, submitting the job into Nomad, and then tailing that job until it completed or didn't complete. Initially, the injection configuration, the part that injected configuration to a service involved roughly the following steps. We'd inject a template for environment variables or for application configuration, if that was on the XML side. We would configure a couple monitoring sidecars, so things that would ship logs or ship metrics to our downstream services, and then vendoring specific template files that were germane to our platform. This was a lovely, readable 20-line for loop. There were a couple functions that we call, but it was pretty easy to maintain and pretty easy to update, and therefore debug and use overall. This lovely piece of code eventually grew into a very large set of modules spanning many thousands of lines of code and many thousands of lines of for loops. We actually had a gigantic, nice inner for loop of 1,000 lines of code that had probably 7 or 8 nested for loops deep. And that covered stuff like auto-scaling rules. How do we auto-scale for a particular environment? Covered monitoring configuration. If you're transitioning from, for instance, Graylog into Datadog, how did we handle that? Constraining specific options for particular teams or particular environments. We didn't allow raw exec, for instance, for non-platform engineers, so we had to constrain that for other things. So that's all to say that this was very, very complicated for us to maintain. It was very easy for us to break the deployment experience for engineers, and very easy for them to get, therefore, upset with us for not providing a deployment experience that we promised. The next iteration of our deployment middleware took inspiration from the Kubernetes world in the form of admission controllers. So if you're familiar with Kubernetes, you have validation controllers or an admission controller that basically submit your job. It can mutate it, or it can reject it and say this is not valid for the platform. In our case, we built a service called NAC, so that's just like lovely middleware right there. And it's short for Nomad Admission Controller that acts as a semi-transparent proxy to Nomad itself. So controllers within NAC were scoped to particular types of functions, such as a controller that disables raw exec jobs. There was a controller that injected the valid data centers for a given environment. There's a controller that enforced version secrets for an application. And then there was a controller that enforces app-specific fault policies. In this particular case, I would recommend building a system such as this if you have a more mature platform team that is willing to write code and needs to have that central configuration for your platform. If you need to enforce rules, this is a great way to enforce those rules and put it in front of Nomad. There's an alternative to this is actually to lint your jobs prior to submission. If you're very comfortable with engineers overriding your rules, you can write basically the same kind of tool, runs on the CLI, you put it in CI, and then you would submit the job, whether or not it was in the proper format. The above changes still describe our initial Deli-based deployment, But in 2021, we took a closer look at how engineers actually used our platform to deploy. They had the following things to say. I don't really understand all the options in a Nomad job specification, so I usually just copy paste the configuration from one job to another. The HCL that I configure and the jobs that get deployed aren't ever really the same because we were mutating them in between. So I don't actually know how to tell whether or not that was something that our platform supports or if that's something that Nomad does. And then finally, I hate copy pasting the same configuration from one job to another, and I always forget to add a particular stanza or it's misconfigured for that particular type of job. And at this point, we took a step back and looked at the various ways that we could unify the configuration that we exposed to engineers. It's culminated in a newer system that we call Rollout. And in this system, we emphasize convention over configuration. So rather than providing the entire Nomad job spec and allowing folks full access to the platform, because we know that all applications are built and run in the same way, we can constrain that to a couple small configuration options. So this means instead of having an 80 plus line HCL job file that defines how to run the entire job, an engineer can just write 5 or 6 lines of code to specify, here's my single process that I need to run. This sort of method for abstracting the configuration into a simpler format is pretty common across companies. So if you go from one company to another, you'll see that there's another configuration format that's similar to this. The unfortunate part of this is that you can't really share this kind of configuration format because it's very specific to how you run applications at your work. I'm happy to talk about this later if you want. I'll show you my spec, but I'm pretty positive that it'll be a different spec if you go to your company or any other place. We also standardized and simplified how external systems integrate with deployments, resulting in many fewer commits to get something deployed. If you've ever worked with CI/CD pipelines, you'll notice that there's probably like 10 or 11 commits before you actually get to actually running your tests. That's something that we wanted to avoid with Rollout. Previously, I mentioned that what we embrace on our end is simplifying interfaces for deployments. And so what we wanted to do with Rollout was expose our deployment platform as an API as opposed to something that we pulled from for you. So in our case, the YAML file that we submit actually is turned into JSON and submitted to an API. And then on that end, we convert that into HCL2 and then finally submit that to Nomad. So if an engineer wants to deploy, they modify their YAML format, they can lint it in CI, that gets submitted into our deployment platform, and we tail logs back for that deployment back to the CI job until completion, whether or not that's pass or fail. I recommend this kind of platform if you have a team that really has a lot of experience writing code and is comfortable managing that platform as opposed to a team that's kind of more configuration driven. And if you have a team that needs to provide standards across your organization for different types of jobs. If you don't have standards across your organization, or if you're trying to define those, this may not be a good fit for you. So with all that in mind, I'm going to go into particular things that we built within our platform. First off, it's secret management, and I want to give you a little bit of how that's evolved over time. For us, secret management is actually pretty interesting. All applications require access to secrets. In Nomad 1.4, have the ability to set secrets directly within Nomad, so they don't need Vault. But in our case, we use Vault, and we wondered how should we expose those environment variables to users? How do we expose configuration and ensure those applications are running in the proper method? Secret management at SeatGeek is pretty interesting. With our initial Nomad setup, we actually had template stanzas that did something like this. So for every single secret that you wanted to pull, you would pull from a path, we would read it in, it was great. This is all KVV1. It worked pretty well for a playground application, but it has a couple sharp edges. In our case, we required specifying every single key for an application, right? So if you needed a payment token and you also needed a payment token for another service, you needed both those keys there. If you had multiple jobs, you also have to specify that template stanza over and over and over for each job, which can be frustrating. And then if you're missing one of these keys, the deployment will just fail just because of how Consul templating work, right? So our first iteration of exposing secrets to applications in production environments was something that we call env-HCL. So you could specify your data store configuration, you can specify a secret, you can specify Consul services that you want to link. And what we would do under the hood is we would take that in, build out, generate that template for you, and then inject that into every single job. right? So pretty useful, pretty easy way for an engineer to add a new secret into their application or add a new data store link, etc. Of course, you still had to configure upstream for Vault access to a particular data store, or you had to inject that secret into that particular environment, but those are kind of standard things. So to add a secret called Lollipop, you add a stanza, it's called secret, with the name Lollipop in there, and then an engineer would go into the path in Vault. It was secret, API, and to their Lollipop environment path, set that value, and then they would trigger a deploy. And then under the hood, when you deployed, our Deli service would read in your HCL stanza, check for that environment variable within Vault and verify that it was there and that had a value, inject the proper template, and then trigger the deploy for you. So it worked pretty well. With the new rollout system, one of the things that we wanted to do was decrease the number of steps that you had to do to add an new environment variable or a new secret. Previously, we would require a user to create a commit in that repository and then trigger a deploy, right? In the case of Vault's Nomad integration, what we would see is sometimes someone would set a variable value to update something that would need to be coordinated with a deployment. And because of how secrets are refreshed on a given interval, that secret would be refreshed prior to that deployment, causing potential issues during runtime. So in the new setup, what we do is we inject the templates kind of like this. You specify the application and the path and the version of the secrets. So we're taking advantage of KVV2 at this point. And what we do is we inject that version of the secret. All secrets are stored as JSON within Vault itself at that Vault path. And so a user would set the Lollipop key inside of your environment, and then we trigger a deploy. So every single deploy is tied to a version of secrets versus having that kind of hang around, right? So under the hood, everything is now stored in that JSON dictionary. And this allows engineers to quickly scan what secrets are available, which is great. Because previously they would say what is available, I don't know what the value is, and they'd have to go through several paths. The secrets are now versioned, and they're versioned up to 100 things, so we know exactly who's changed something and when they changed, and we can revert if we need to. And then deploying a secret is actually an explicit action that an engineer takes, so they can coordinate that with application changes that they might need to, right? So it works pretty well for us. If you have something similar or a setup that's pretty similar, this might be a great avenue for you. The next thing we have is on observability. Our application monitoring stack has gone through a couple different iterations and how we provide monitoring for logs or metrics and that sort of thing. And initially what we had was we had folks copy pasting configuration into their applications. There was a configuration for a FileBeat sidecar so they could ship logs. There's configuration for a Telegraph sidecar so they could ship metrics, etc. And this worked fairly well, but it didn't work for very long. The application monitoring space progresses extremely quickly, we found, and both at SeatGeek and external to us, right? So if we're using a tool, that tool may change how it gets configured, or that, we might find that another platform or another provider is more useful. And so requiring an engineer to make that change every single time the resilience team, investigated a new, better tool and provided better experience meant that that was taking away from engineers, productivity and the ability to ship product to our customers. And it was also, again, something that they needed to copy paste for every single job, and something we wanted to avoid. So the first generation of this was just template based, as I mentioned. So you'd inject a FileBeat YAML file or New Relic config or Telegraph, etc. And what we would do under the hood is we would read that job, read every single configuration file, inject the proper sidecar depending on what configuration files were available, and then deploy. All right, so if you had a FileBeat YAML file, maybe we had some token that we needed to inject, the deployment system would read that FileBeat, interpolate variables, inject that template, and then submit the job. Early on, we would detect features based on the existence of these files, right? So if you wanted APM, for instance, we would inject the APM only if you had the New Relic config in place. Or if you wanted to ship logs, we would only ship logs if you had FileBeat in place. And that was good because then an engineer could say, I'm doing my operations in X way, I'm shipping my logs in Y format. It didn't work really well if an engineer forgot one of these files. So they would ask, why are my logs missing? Or why am I not collecting metrics? It didn't work really well if your application was kind of shipping things in different formats. So we have some applications where they might have, for the most part, Python logging to JSON, but maybe they have an Nginx process that's running because it's running some static process, I don't know. And that Nginx process is logging in a different format. So it's not really well suited for those kinds of setups. So rather than letting this be open-ended, our deployment tooling is now injecting all of this information. So in the Deli, when we're still using Deli, we started injecting the configuration via the Docker file, which we found was the closest thing to the actual running process, right? So if you're running Nginx, you can specify that my log format is in JSON or in Nginx format. If you're running your application, we specify the standard is JSON format, but you can override that via a label. Right? This has worked pretty well. Downstream, the agents that we use to ship metrics and ship a log and provide APM services can introspect on those labels and then provide the services as necessary. It does require a little bit more work in terms of integrating those agents with your running applications, and it doesn't work quite well if you have non-container-based deployment systems. So if you're deploying via raw exec jobs or you're deploying some other thing, maybe you don't have that capability there. So I do want to recommend that you only use this pattern if you're fairly homogeneous and have standardized on some specification where you can introspect on that. Similarly, one of the other things that we provide is the ability to, in Deli at least, to override configuration on a per job basis, right? So if for whatever reason you have a single Docker file that runs multiple processes but have slightly different config, you can kind of go back and say, all right, fine, I'm going to override just on that application, on that process setup. Again, the one nasty thing about this is that you might need to duplicate that configuration. If you have multiple jobs and you need to specify these 3 jobs are Nginx, you need to re-specify that over and over and over. That might get unsynced with your underlying code base. So if your code base now for whatever reason changes to a proper format or a different format, you need to go and find the places where you've referenced that. And adding support for new configurations means that you need to expand the set of labels, right? So if you want to expose maybe HTTP processing or something or HTTP monitoring, now that's a new configuration that you expose. In the rollout world, we actually make a ton of assumptions about what the best setup is for folks. And then we remove all of the knobs completely. So if you're an engineer, we expect you to log via JSON. If you can't log via JSON, we need to talk. And we need to figure out a workaround for you. Rather than exposing all of these knobs for you and making it more confusing, standardize the system so that way we can do the things in the most efficient manner, right? Similarly, we make some assumptions about how metrics are collected and how we inject APM configuration into applications. So one nice thing about this is that we can have a unified answer as to why a system works in a certain way, why are we shipping X, or why are we ingesting something in Y format. Because it's the same everywhere. We don't have to do something that's application or process specific. This has also cut down on a ton of support requests because an engineer can go from one team to another and they have the same kind of experience across teams. The one pain point is that when we're migrating systems or we're updating configuration, you have to upgrade that kind of everywhere. And it's not a piecemeal operation. So you need a little bit more thought and care into that sort of pattern. The last thing I want to go into is networking. We at SeatGeek embraced microservices really, really early on. Like 2010, we had microservices, and then I think 2012, people were calling it microservices, and that was really interesting for us. For us, it was largely an attempt to isolate older frameworks from newer code, right? So if you're running, in our case, we had a Symfony 1.1 app that we didn't want to continue working on, and folks were writing Python code. We started using microservices to push more of that logic into separate services. This happened prior to our adoption of containerization and Nomad, by which point we had about 40 applications running maybe 100, 200 services. We're quite a bit bigger now than then, but it's pretty much the same networking model. So initially, engineers would set up environment variables to talk across services. We assign a well-known port to a service, and you can talk to localhost on that port on any given box, and we would then ship your request off to the correct service. That was all done via a load balancer that was applied to every single server. So if you were on any given server, you can talk to the API via the same port or you can talk to our map service via the same port. There wasn't any guessing. And a lot of that was hard-coded into your service. So if you needed to talk to that service, you read a file that said, this was the mapping. All right, great. I'm going to use that in my application. But for the most part, folks were reading this via environment variables. And the nice thing about that was that it allowed folks to locally run that service on different ports and then do that cross-service communication. So we were kind of ready already to shift into a more service mesh-based approach. Right. Our first iteration of service communication on Nomad, we piggybacked off the HCL file format. So we had a way for a user to define a service. You can define that service on a given scheme. You can define it on a given port. You can define what service it talked to under the hood and expose that in a different environment variable depending on what you wanted to do. We would of course process that and then inject the Consul template for usage. And then you would talk to whatever that registered service was. Pretty simple. I think this is pretty straightforward if you just are getting started with Nomad and you have Consul set up, or if you're using the Nomad's integrated service communication. This is probably the way that you want to go. In our case, you have to be more, or what we found is that you have to be kind of careful depending on how many services you have and how you're loading up those templates, especially if you're like iterating over a lot of stuff. Some things that we found early on was with much smaller Consul clusters, we overloaded the Consul cluster and had a ton of outages because we were trying to render these very large, very complex Consul templates. So keep in mind that if you're deploying this kind of functionality, test it in pre-production. Your pre-production is probably a lot smaller than your production. So multiply by whatever number of requests or services you're like templating out. Our current iteration is fairly similar. You know, an engineer defines their configuration in a rollout YAML file, and then what we do is we inject that rollout YAML file configuration, and we inject a sidecar for the engineer. We also inject the environment variable with the correct value. So under the hood, they talk directly to the service via Consul Connect, and I don't have to do really too much of anything different, right? And that also applies to our existing Deli based deployments. They define the HCL file, we turn that into the correct Consul Connect configuration and inject that for an engineer. I think this allows us to have a much more secure communication across services, and hopefully in the future allows us to shut down requests outside of the mesh from servers. I recommend looking at this route if you're comfortable with Nomad's current Consul Connect usage instructions. Specifically, there are a lot of things that you might want to configure on the Consul Connect side that aren't quite exposed to users via Nomad. If you're on something like Kubernetes, you have kind of full reign of everything, but on the Nomad side, there are a couple options that may be useful, but just aren't exposed quite yet. And might require you to build tooling and that sort of thing to push them out via APIs. And that's all I've got. So if you're still here, my Twitter handle is Savant. You can come and reach me after the talk or reach out on Twitter, and hopefully someone's learned at least one thing here. Thank you.